Welcome and study with Tanzania Institute of Education.
Hello, my student. My name is Levocatus Joseph Mbuga. I'm a teacher of chemistry. Today, I'll be with you, and we are going to solve question for general chemist as a revision for Form 6 student. The general chemistry have many aspects or subtopic. The subtopic which we are going to discuss today is a chemical bonding. Let us start with question number 1. Okay, my dear students, in order to determine the hybridization of ASCII atom, consider the central atom of molecular given. Here the central atom of carbon dioxide is on carbon. So in order to predict the hybridization of carbon, consider electronic structure of carbon at ground state, electron field according to node of increasing energy level. Then consider carbon at excited state, electron promoted from 2s to vacant orbit of 2p. So for formation of molecule of carbon dioxide combined with the 2 atoms of oxygen. Carbon here have 4 unpaired electrons, and oxygen have 2 unpaired electrons. So during chemical combination of carbon and oxygen donates 2 pairs of electrons to carbon which have 4 unpaired electrons, which is that formation of double bond. One bond is sigma and another pi. For 2 oxygen atoms, the 2 sigma bond are formed and the 2 pi bond are formed. So for hybridization, the electron considered should be those electrons involved with the formation of sigma bond. So electron involved in the formation of sigma bond include the first electron and the second. The third one and the fourth one did not involve in the formation of sigma bond, participated in the formation of pi bond. So the hybridization of carbon here is 1 electron in S and 1 electron in P. So hybridization of carbon is sp hybridization. The hybridization of carbon enables us to determine the geometrical shape of molecule of carbon dioxide. Since the carbon dioxide molecule have sp hybridization, the geometrical shape of molecule of carbon dioxide should be linear shape. Why should be linear shape? The carbon atom have 4 pairs of electrons. That 4 electrons involved in the formation of 2 double bonds. Both 2 double bonds have equal extent of repulsion, and the result pair of electrons which involve in the formation of bond move far away from each other, and the result molecule of carbon dioxide display a linear shape which having an angle of 180 degrees. Question 1A, Roman number 2, phosphorus pentachloride. Predict the hybridization of central atom, which is phosphorus. At ground state, the outermost subshell of phosphorus filled in 3s, 3p, and 3s and 3p. D is vacant or empty. At excited state, electron promoted from 3s to 3d, which is that phosphorus to have 5 unpaired electrons. So during chemical combination between phosphorus and the chlorine have only 1 unpaired electron, combined with the phosphorus having 5 unpaired electrons. Through combination, result all 5 unpaired electron phosphorus involved in the formation of sigma bond, and the hybridization of central atom known as phosphorus become S, which have 1 unpaired electron, and the P having 3, and the D having only 1. So hybridization of central atom known as phosphorus is F3D, or sometimes can be written as DsP3. The hybridization of central atom sp3d applied to predict the geometric shape of molecular phosphorus pentachloride. According to this kind of hybridization, geometrical shape which can be displayed by phosphorus pentachloride molecule is a trigonal bipyramidal shape. This geometrical shape, it has 2 pyramid and it has 1 triangle. So there is trigonal and 2 pyramidal. So the geometrical shape of phosphorus pentachloride is trigonal bipyramidal. Okay, for question number 1A, Roman number 3, predict hybridization of central atom of sulfur trioxide. The sulfur at ground state have outermost sub-energy level CS3P3D. So electron filled node of increasing energy level. Here the oxidation state of sulfur is almost 6. So you are supposed to display or to promote electron. One from 2p to vacant orbital D, and another electron from 3s to 3d, which results sulfur to have 6 unpaired electron. One sulfur combined with oxygen, sulfur have 6 unpaired electron, and if have 6 unpaired electron, oxygen have 2 unpaired electron. So once sulfur combined with the 3 oxygen atom, there is formation of 3 sigma bond, and there is formation of 3 and pi bonds. So these 3 sigma bonds involved in hybridization. So the hybridization of central atom known as sulfur is sp2. 1 electron used in s orbital and the 2 electrons used in p orbital. According to this kind of hybridization, sp2, the geometrical shape which can be displayed by sulfur trioxide molecule is a trigonoplanar, or sometimes is known as triangular planar. That triangular planar have central atom sulfur and bonded to 3 atoms of oxygen, and the result formation of trigonal planar, or sometimes known as triangular planar. So this is a geometrical shape of sulfur, and all 3 double bond have equal extent of repulsion, and the result to have bond angle 120. Okay, question number 1. A, Roman number 4, predict hybridization of central atom and geometrical shape of sulfate ions. First, find oxidation state of sulfur and use that oxidation state to light number of unpaired electron of sulfur. Sulfur at ground state have outermost shell number 3 having sp and d subshell, electron filled in 3s and 3p, In order to have 6 number of unpaired electron, 1 electron from p and another 1 electron from s orbital promoted toward the vacant d orbital, which result sulfur to have 6 number of unpaired electron. Sulfur having 6 number of unpaired electron combined with the 4 molecule of oxygen. 1 oxygen have 2 pair of unpaired electron. If you have 2 unpaired electron, once combined, sulfur brings 6 unpaired electron, but among these 6 unpaired electron, 4 unpaired electron of sulfur involved in the formation of sigma bond, and these 2 unpaired electrons involved in the formation of pi bond. These 4 unpaired electrons which involved in the formation of sigma bond considered to be hybridized, and these 2 which are not yet used are not considered to be hybridized. So these electrons are hybridized, but only 4 electrons of sulfur hybridized. So hybridization of sulfur is 1 electron in s orbital and 3 electron in p orbital. So hybridization of sulfur is sp3. Geometrical shape. The geometrical shape of molecule of sulfate ions is known as angular shape. According to the structure of these sulfate ions, sulfur combined with 4 oxygen atoms. 1 oxygen atom formed the double bond with the sulfur, and another oxygen atom formed double bond with the sulfur, and third one, the fourth one, formed only a single bond with the sulfur. According to valence shell, electron pair, the partition theory, this double bond exert a greater repulsion force upon the bond electron of sigma. Result, bond electron of sigma bond move far away from double bond, and result sulfate ion to have angular shape. That angular shape of sulfate ions can be drawn as shown here. This is an angular shape of molecule of sulfate ions. And the sulfate molecule, it has negative ion, so it should be enclosed with square bracket, and the charge of sulfate ion should be written above on the right side. So this represents a molecule of sulfate ions displayed an angular geometrical shape. Question number 1B, asked to predict the bond angle of carbon which combines with the 2 chlorine, and to compare the molecule of carbon which combines with the 2 atoms of chlorine and the boron which combined with the 3 atoms of chlorine. Which molecule having large bond angle? For carbon which combined with the 2 atoms of chlorine, central atom is carbon, and the carbon at ground state have outermost shell which have 2 pairs of electrons in 2s orbital and 2 unpaired electrons in 2p orbital. At excited state, the sp hybridized. What does it mean? The electron which used to form this molecule of carbon combined with 2 chlorine, the carbon used only 2 unpaired electrons. So there is no need of hybridizing the electron from 2s orbital. So if these two electrons are used to form this molecule of carbon having two atoms, it has sp2 hybridization. It means that the molecule of carbon which combine with the two atoms of chlorine having one lone pair and the two pair of bonded electrons. According to valence shell electron pair repulsion theory, lone pair exert a greater repulsion force upon two bond electron pair. These two bond electron pair move away from lone pair to minimize repulsion force and to maintain chemical stability. That movement of these two unpaired bond electrons result a bond angle of carbon having two chlorine to have very, very small bond angle, which almost is smaller than 180. But for boron, combined with the three atoms of chlorine or boron trichloride, boron is a central atom. At ground state, it has two electrons in the outermost s orbital and the 2p orbital. Oxidation state of boron here, boron used the three electrons to combine with the three atoms of, so these two electrons in the outermost subenergy level S2s should be promoted to vacant orbital of subshell 2p. Result to have how many unpaired electrons? 3. Hybridization of boron is sp2. What does it mean? One electron in s orbital and the two electrons in 2p orbital. So boron, which combine with the three atoms of chlorine or boron trichloride, have three bond electron pair. And these three bond electron pair have equal repulsion force and move far away from each other, which display a geometrical shape having bond angle 120. The bond angle 120 is greater than bond angle of carbon, which combined with the two chlorine atom and having one lone pair. So carbon having two chlorine have smaller bond angle compared with the boron combined with the three atoms of chlorine. My student, let us go question number 2A, Roman 1. Compare bond angle between ammonia and methane. Let us start with molecule of ammonia. Nitrogen at ground state have outermost shell number 2, which have subshell 2s and subshell 2p. Subshell 2s has two electrons which occur in pair, and the 2p have 3 electrons which occur unpaired. So when nitrogen combine with hydrogen, use 3 unpaired electrons in the 2p orbital. So molecule of ammonia, it has one lone pair of nitrogen. That lone pair exerts a greater repulsive force upon a bond electron pair. The bond electron pair move away from lone pair to minimize repulsion force and to maintain chemical stability, which result bond angle of ammonia molecule decreases and become smaller than bond angle of methane. For methane, the carbon atom at ground state, it has almost 4 electrons in the outermost shell. 2s contain 1 pair of electrons and the 2p having 2 unpaired. Through hybridization, 1 electron from 2s is transferred to vacant orbit of 2p, which result carbon having S3p hybridization. That 4 unpaired electrons are used to make a molecule of methane. So carbon combined with hydrogen by using all 4 unpaired electrons and they form all sigma bonding. So methane have no lone pair. That 4 bond electron pair repel in equal strengths, and if repel in equal strengths, move in all direction, and the result bond angle of methane is larger than bond angle of ammonia. The bond angle of methane measured and was found to be 109 degrees. The bond angle of methane cannot be 90 degrees because the bond electron pair of all 4 bond electrons continue to repel each other, and the result, the bond angle move away from, the bond electron pair move far away from each other, and cause the bond angle of methane cannot be exactly 90, and they become greater than 90. Okay, let's go. Question number 2, Roman number 2. This question asks us to account why the bond angle decreases from methane, ammonia to water molecule. According to valence shell electron pair repulsion theory, molecular have bond electron pair. Bond electron pair repel each other, and the result movement of bond electron pair far from each other to minimize repulsion force and to maintain chemical stability. The movement of bond electron pair and atom can be measured in terms of angle. So all molecules have bond angle, and that bond angle are not equal, are different. To know that this molecule of different substances have different bond angle, consider molecule of methane, ammonia, and water molecule. Let us start with molecule of methane. Carbon at the ground state have 1 pair of electrons in its 2s orbital and 2 unpaired electrons in 2p orbital. Once combined with the hydrogen, carbon undergo hybridization by promoting electron only 1 from 2s to 2p, which result carbon at excited state to have 4 unpaired electrons. That unpaired electron combined with unpaired electron of hydrogen result methane to have 4 bond electron pair. That 4 bond electron pair repel equally and they move in all direction, which result methane to have large bond angle than ammonia and the water molecules. For ammonia molecule, nitrogen have 3 bond electron pair, 1, 2, 3, and 1 lone pair. Lone pair of nitrogen exert a greater repulsive force upon bond electron pair. The bond electron pair move far away as possible from lone pair, which reduce the bond angle of ammonia. So ammonia have a smaller bond angle than methane. And for water molecule have oxygen as a central atom, which have 1 pair electron through s orbital, and in 2p orbital there is 1 pair of electrons and 2 unpaired electrons. Once oxygen combined with 2 atoms of hydrogen, the water molecule formed have 2 lone pair of oxygen and 2 bond-electron pair of oxygen and hydrogen. 2 lone pair, this one, exert strongly repulsion force upon a bond-electron pair. This bond-electron pair move away from these 2 lone pair, which result water molecule have smallest bond angle than ammonia and the methane. So the bond angle decreases from methane, ammonia to water molecule. This contributed by presence and increase of lone pair. For example, ammonia have 1 lone pair and oxygen of water molecule have 2 lone pair. So 2 lone pair exert a strong repulsion force than only 1 lone pair. And that water molecule have smallest bond angle compared to ammonia molecule. Let's go into question number 2B. This question have 2 chemical compounds. The first one, hydrazine, and the second one, ethene. This question asks us to compare boiling point of hydrazine and ethene. First of all, boiling point of any compound depend on molecular weight of that compound. So hydrazine, it has molecular weight which determine boiling point of hydrazine, and the ethene have molecular weight which determine boiling point of ethene. So for hydrazine, it has nitrogen. That nitrogen bonded to hydrogen atom. Nitrogen is more electronegative than hydrogen. So nitrogen withdraw bond electron pair from hydrogen, which result hydrogen, which bonded to nitrogen, become polarized positively, partially positively, and the nitrogen become polarized negatively. Polarization of bond electron pair is known as dipole moment. The polarization of hydrogen is one condition necessary for formation of hydrogen bond. So hydrazine have an ability to form hydrogen bonds. So if hydrazine molecule or compound placed in a certain container, that container will have many molecules of hydrazine. So this molecule of hydrazine associate by hydrogen bonding. Associate by hydrogen bonding. How this molecule associate? The nitrogen of one molecule having lone pair donate the lone pair to the hydrogen of another molecule which polarized positively, and there is that formation of hydrogen bond. Formation of hydrogen bond between molecules of hydrazine increase intermolecular force of hydrazine, which contribute the hydrazine to have higher boiling point than ethene. For ethene, having carbon atom, 2 carbon atom bonded by double bond, and each carbon atom bonded to hydrogen. Carbon and hydrogen have very, very small electronegativity difference, so carbon have no ability to polarize hydrogen bonded to carbon positively. So ethene have no any condition required for making hydrogen bond. So the ethene have no association by hydrogen bond, but it has weak intermolecular force which contributed by molecular weight of ethene. That weak intermolecular force contribute molecule of ethene to have very low boiling point compared to the molecule of hydrazine. Let's go into question number 3. Before looking at this question, how asking, we are supposed to know the molecular or chemical compounds which made up by covalent bonds or any covalent compound or molecule can be classified into 2 categories. There are non-polar compound and polar compounds. So to identify which molecule or which compound is polar and which molecule or which compound is non-polar, let we solve this question number 3, Roman 1. Roman 1, identify if molecule of carbon dioxide is polar or non-polar. Okay, before discussing carbon dioxide is polar or non-polar, we are supposed to know factor which determine the molecule or compound to be polar or non-polar. First of all, that molecule or compound should have most electronegative atom bonded to less electronegative atom, or between 2 bonded atoms should have larger electronegativity difference. That is factor number 1 in order to be polar compound or molecular. Factor number 2, for compound to be polar or non-polar, it depends the geometry shape of that molecule or compound. So there are 2 factors which determine molecular or compound to be polar or non-polar. By using these 2 factors, let me use it to find given molecular or compound to identify if is non-polar or polar compound. Let me start with Roman 1, carbon dioxide. So carbon dioxide have central atom known as carbon bonded to oxygen, 2 atoms of oxygen by double bond. Carbon is group number 4 and oxygen group number 6. So oxygen is more electronegative than carbon. Oxygen withdraw electron from carbon, which result oxygen become polarized negatively and carbon become polarized positively. So the bond between carbon and oxygen is polar. But how about the geometrical shape of carbon dioxide molecule? The geometrical shape of carbon dioxide molecule is a linear shape. The linear shape shows that the force which attracting electron from central atom or the force exerted by oxygen of withdrawing electron from carbon for this linear structure occur in opposite to each other, which result 2 force of withdrawing electron from carbon cancel from each other. As a result, there is no polarization of carbon and oxygen which bonded together in the molecule of carbon dioxide. As a result, carbon dioxide is a non-polar molecule. For carbon dioxide, which is non-polar molecule, let me shift into Roman 2, beryllium fluoride. Beryllium fluoride have central atom which is beryllium bonded to 2 atoms of fluorine. I think you know fluorine is group 7, beryllium group 2 in the periodic table. Fluorine, which bond to beryllium, are more electronegative than beryllium. So fluorine withdraw electron from beryllium, and the result, fluorine become negatively charged, beryllium become positively charged. Since the geometrical shape of beryllium fluoride is a linear shape. Like carbon dioxide, the resultant force of withdrawing electron in a beryllium fluoride is equal to 0. There is no any electron or bond electron from beryllium withdrawn by fluorine, because force of attracting or withdrawing electron cancel from each other. As the result, fluorine cannot be polarized negatively and the beryllium cannot be polarized positively. As the result, the beryllium fluoride have no dipole moment or have no partially charged ion, which result beryllium are non-polar molecule like carbon dioxide. For carbon monoxide, Roman 3, carbon monoxide have carbon atom and oxygen atom bond together by double bond. Oxygen group 6, carbon group 4. Oxygen is more electronegative than carbon. So oxygen withdraw bond electron pair from carbon. Oxygen become polarized negatively and carbon become polarized positively. The geometric shape of carbon monoxide indicate there is resultant force. So carbon and oxygen having partial charge existing in the molecule of carbon dioxide, and the result molecule of carbon monoxide is a polar compound, which differ from carbon dioxide. Carbon dioxide is non-polar, but carbon monoxide is a polar. Geometrical shape of carbon monoxide favor the molecule of carbon monoxide is polar, having dipole moment or having partial charged ions. Positive for carbon, which is less electronegative, and the negative charged ion of oxygen, which almost account the molecule of carbon monoxide is a polar compound or molecular, while carbon dioxide is a non-polar. For Roman number 4, sulfur dioxide molecule have sulfur bonded to 2 atoms of oxygen. But central atom of sulfur dioxide, which is sulfur, have 1 lone pair remained. That lone pair exert a greater repulsive force upon the bond electron pair, which result bond electron pair of oxygen and the sulfur move away from lone pair to minimize repulsion force and maintain chemical stability. So according to position of sulfur in the periodic table and the oxygen, sulfur is less electronegative and oxygen is most. So oxygen withdraw bond electron pair from sulfur. Oxygen become polarized negatively. Sulfur become polarized positively. How about the molecular shape or geometrical shape of sulfur dioxide molecule? The molecular geometrical shape indicate the resultant force of attraction. There is resultant force. It means that the force of withdrawing electron from sulfur by each oxygen atom existing, and the result the existence of dipole moment, which causes sulfur dioxide molecule is a polar molecule. And for last molecular given, which is water, water have central atom oxygen bonded to 2 atoms of oxygen, but central atom of oxygen have 2 lone pair. That lone pair exert a strong repulsive force upon the bond electron pair, and these move away from lone pair and display this known as angular geometrical shape. So how about electronegativity difference? Oxygen is more electronegative than hydrogen, so oxygen withdraw bond electron pair from hydrogen. Oxygen become negatively charged, and both 2 hydrogen become polarized positively. And these partial positive and negative charge exist in a molecule of water, or dipole moment in the molecule of water exists, which result water molecule is a polar molecule or polar compounds. So in order to determine any given molecule or compound, if non-polar or polar, compare two factors: electronegativity difference between the bonded atom, and the second, consider geometrical shape of that molecule. Question number 3, Roman 1. So before solving this question, we are supposed to know that chemical bond is an interaction process which results in association of atoms or ions to form molecule or compounds. So the mechanism how atom or ion interact depend what kind of bond formed between two bonded atoms. If the mechanism how the molecule or the compound formed by interaction of different atom or ions depend the kind of bond which formed, let's observe given molecule and the compound how is formed by combination of atoms or ions. Let us start with nitrogen. Nitrogen, non-metallic element, combine themselves and form nitrogen gas. So nitrogen gas is a molecule. From electronic structure of nitrogen, the outermost shell or valence shell of nitrogen have 2 electrons in s orbital and 3 electrons in 2p orbital. So nitrogen have 5 outermost valence electrons. Among these 5 valence electrons of nitrogen, 3 unpaired electrons and only 1 paired electrons. So once 2 atoms of nitrogen combine, with that formation of molecule of nitrogen gas, the kind of bond which formed between 2 bonded nitrogen is called covalent bond. So covalent bond is formed by sharing of unpaired number of electrons. So nitrogen atom have 3 unpaired electrons, and another atom of nitrogen have 3 unpaired electrons. So these 2 atoms combine by sharing these 3 number of unpaired electrons, which result formation of triple bond. There is formation of triple bond between 2 atoms of nitrogen. So nitrogen is a molecule having covalent bond. For Roman 2, hydrogen sulfide. This is a compound having hydrogen and a sulfur. Having hydrogen and a sulfur. This compound, having hydrogen and a sulfur, these 2 atoms combine by sharing of electrons. So hydrogen sulfide is a covalent compound. Is a covalent compound formed by sharing of unpaired electrons. So consider electronic structure of sulfur at ground state. It has 6 valence electrons in the outermost shell, or 6 valence electrons in the outermost valence shell. So among these 6 valence electrons, sulfur have 2 unpaired electrons and 2 pairs of paired electrons. So once sulfur combine with hydrogen, use these 2 unpaired electrons. And according to electronic structure of hydrogen, hydrogen have only 1 unpaired electron. Use that 1 electron to combine with the sulfur by sharing. Since sulfur have 2 unpaired electrons, and the hydrogen have only one sulfur combined with 2 atoms of hydrogen in order each atom to contribute equal number of unpaired electrons. So a structure of hydrogen sulfide, which is a covalent compound, is shown by using unpaired electron of sulfur and unpaired electron of hydrogen. So a bond between sulfur and hydrogen is covalent, and another second bond is covalent. So this is a Lewis structure, or is a structure of hydrogen sulfide, which is found by sharing of number of unpaired electrons. And the last question, Lohmann 3, sodium fluoride. Sodium fluoride is a chemical compound which contains sodium and fluorine. Sodium, metallic element, and the fluorine is a non-metallic element. Metal and the non-metal combined by transfer of electron. And the type of bond formed between sodium and fluorine is the ionic bond or covalent bond. That bond is formed by transfer of electron. So according to electron structure of sodium, sodium have only one electron in the outermost valence shell. So the valence of sodium is only 1, ionized by losing 1 electron. For fluorine, have outermost electron, which occur in 2s orbital and 2p. These are 7 outermost electrons. But these 7 outermost electrons of fluorine, only 1 is unpaired electron and have 3 pair of electrons. So sodium, when combined with the fluorine, sodium lose only 1 electron, become positively charged, and fluorine accept only 1 electron, become negatively charged. So the bond which occur between sodium ion and the fluorine ion is ionic bond. So for ionic bond, the ions which interact and the atom which combine should be enclosed by using square bracket. But for covalent bond, no need of enclosing the atom which combine by using square bracket. So this is electronic, it's just a Lewis structure of sodium fluoride ionic compound. My student, go and do revision exercise 2, page number 83, which is found in the general chemistry books for advanced level secondary school, written by Tanzanian Institute of Education. Goodbye.
Let's study, be educated, elimu ni kazi. Elimu ni kazi. Let's study, be educated.